A lot of people ask me, what's the next big thing? Where is the future being built? And while Silicon Valley has been the default answer for decades, the reality on the ground is, well, it's shifting. The rate of progress, the sheer scale of ambition I'm seeing coming out of China, is something that demands our attention. It's not just about copying anymore, it's about fundamental, first principles-based innovation. We're talking about a technological ecosystem that's evolving at an exponential rate, a kind of Cambrian explosion of new ideas and hardware being deployed into the real world. It's fascinating, and frankly, a little bit daunting. This isn't just about another app or a social media platform. We're looking at a fundamental rewiring of society itself, driven by technologies that were considered science fiction just a few years ago. By 2025, the landscape will be almost unrecognizable. The convergence of AI, robotics, new energy sources, and biotechnology is creating a flywheel effect. Each breakthrough accelerates the next, and China is positioning itself right at the nexus of this convergence. It's critical to understand what's happening, not from a place of fear, but from a place of curiosity and a desire to understand the future of humanity. So today we're going to take a hard look at the specific technologies that are putting China at the forefront of the innovation charge. We'll break down the engineering, the deployment, and the societal implications of what's unfolding. This isn't a political discussion, it's a technological one. It's about understanding the physics of progress, the engineering challenges being solved, and what it means for all of us. Let's dig into the data and see what the future as it's being built in China actually looks like. It's going to be an interesting ride. Quantum computing. It's a term that gets thrown around a lot, often with a mystical quality, but it's not magic, it's just incredibly complex physics. The core idea is moving from bits, zeros and ones, to qubits, which can be a 0, a 1, or both at the same time, thanks to superposition. This exponentially increases computational power. While many are still in the theoretical or small-scale lab phase, China has been pursuing this with an almost singular focus, viewing it as a matter of national strategic importance. It's a high-stakes game for computational supremacy, and they are playing to win. The team at the University of Science and Technology of China, led by Pan Jianwei, has been making some pretty incredible strides. They've demonstrated quantum supremacy with two different technical approaches. Media Group. Photos of Zhujiang quantum computer prototype. Scientists working with photon detectors I stock could distribute equally, one using photons, which they named Zhujiang, and another using superconducting circuits, called Zhuchangzi. This isn't just an academic exercise. By mastering different pathways, they're not just hedging their bets. They're creating a robust, multifaceted understanding of the fundamental challenges, which accelerates the entire field. It's a very sound engineering approach to a deeply complex problem. The practical applications are where things get really interesting, and frankly, a little scary. A fault-tolerant quantum computer could, in theory, break most modern encryption. Everything from your bank account to national security secrets relies on cryptographic standards that are computationally infeasible for classical computers to crack. A powerful quantum machine changes that equation entirely. This is why the race is so intense. China isn't just building a faster computer, they're building a key that could potentially unlock the world's digital secrets. But it's not all about code breaking. The positive applications are profound. Quantum computers will allow us to simulate molecular interactions with perfect accuracy. This could revolutionize drug discovery, allowing us to design new medicines and cures for diseases like Alzheimer's or cancer in a fraction of the time. We could design new materials with incredible properties, like room-temperature superconductors, which would completely transform our energy grid and transportation systems. It's a tool for understanding the very fabric of reality. The Chinese government's role in this cannot be understated. They've poured billions into national laboratories and research initiatives, creating an ecosystem that attracts top talent and provides them with the resources to tackle these grand challenges. This level of coordinated long-term investment is difficult to replicate in other parts of the world, where research funding can be subject to short-term political and economic cycles. It's a strategic, patient investment in a fundamental technology. By 2025, we won't have a quantum laptop on every desk. That's not the point. The point is that China is on a trajectory to have the most powerful computational devices on the planet, accessible via the cloud to their researchers and industries. This access will create a significant advantage in Media Group. Scientists in materials lab, pharmaceutical researchers at work, financial analysts using computer models, AI robots being developed, AI stock distribute equally, materials science, pharmaceuticals, financial modeling, and AI development. They are building the infrastructure for the next generation of discovery, and their lead in this area is becoming increasingly significant. The global leadership aspect is a direct consequence of this focused effort. When you publish groundbreaking results, attract the best minds, and demonstrate practical applications, you naturally become the center of gravity for that field. Other countries are now playing catch-up. The race for quantum supremacy is not just a scientific competition, it's a geopolitical one. And right now the data suggests China is pulling ahead, setting the pace for what will be one of the most transformative technologies of the 21st century. The idea of a humanoid robot has been a staple of science fiction for a century. We've seen countless prototypes over the years, many of which were clumsy, slow, and incredibly expensive. The fundamental challenge has always been a combination of hardware and software, actuators, sensors, power sources, and the AI, to make it all work together in the real, messy world. What's happening in China now is the rapid convergence of solutions to these problems, driven by a massive manufacturing base and an urgent need for labor. Companies like Unitree Robotics and Fourier Intelligence are not just building one-off demonstration units, they are pushing for mass production. Think about how the cost of drones or smartphones plummeted as manufacturing scaled up. The same principle is now being applied to humanoid robots. By leveraging China's unparalleled supply chain and manufacturing expertise, they are driving the cost of these complex machines down at an astonishing rate. We're talking about moving from hundreds of thousands of dollars per unit to tens of thousands, and the path to even lower costs is clear. Accessibility is the key here. When a humanoid robot costs less than a luxury car, the economic calculation for businesses changes dramatically. Suddenly it becomes feasible to deploy them in warehouses, on factory assembly lines, in logistics, and even in elder care. The affordability makes them a practical tool rather than a research project. In China, where demographic shifts are creating labor shortages, this is not a luxury, it's a necessity. The robots are being designed to work alongside humans, taking over tasks that are repetitive, strenuous, or dangerous. The impact on industries is going to be profound. In manufacturing, a humanoid robot offers flexibility that a traditional, bolted-down industrial arm cannot. It can move between workstations, pick up different tools, and adapt to new tasks with a software update. In logistics, they can unload trucks, sort packages, and handle last-mile delivery. In healthcare, they can assist nurses with lifting patients, delivering supplies, and providing basic monitoring, freeing up human staff for more complex, empathetic care. This isn't about replacing every human worker, it's about augmenting human capability. The software is arguably the most critical piece of the puzzle. The hardware is becoming a solved problem, but the AI that allows the robot to perceive, navigate, and manipulate its environment is the real frontier. Chinese AI companies, powered by the vast amounts of data generated within the country, are developing sophisticated models for bipedal locomotion, hand-eye coordination, and natural language interaction. They are training these robots in virtual environments first, then transferring that learning to the physical world, creating a rapid feedback loop of improvement. Consider the societal implications. As these robots become more common, our entire urban landscape will start to change. We'll see them on construction sites, maintaining public infrastructure, and even performing services in retail and hospitality. This will free up human potential to focus on more creative, strategic, and interpersonal endeavors. Of course, there are massive questions we need to address around job displacement and retraining, which is a serious societal challenge that needs to be solved. But the potential for a future of abundance, where dangerous and dull work is automated, is very real. By 2025, China will not only be the world's largest producer of humanoid robots, but also the largest user. They are creating a domestic market that serves as a massive testbed, allowing them to refine the technology at a scale no one else can match. This isn't just about building the robots, it's about building the entire ecosystem around them. The software platforms, the maintenance networks, the charging infrastructure. They are building the full-stack solution for the robotics age, and the world will be watching very closely. Urban traffic is a fundamental problem of geometry and physics. You have a limited amount of space and a large number of vehicles all trying to occupy it at the same time, operated by fallible human drivers with varying reaction times and attention spans. The result is gridlock, accidents, and wasted time. The logical first principles solution is to remove the least reliable component, the human driver. Driverless taxis or robo-taxis represent a systematic approach to optimizing urban mobility, and Chinese cities are becoming the world's largest proving grounds for this technology. Companies like Baidu's Apollo, Pony.ai, and AutoX aren't just running limited trials. They have deployed large fleets of fully autonomous vehicles in major cities like Beijing, Shanghai, and Shenzhen. We're talking about services where you can hail a car with your phone, and it arrives with no one in the driver's seat. This level of deployment is staggering. It requires not just incredibly advanced AI, but also a massive investment in high-definition mapping, sensor calibration, and remote operation centers. The widespread adoption is being accelerated by a combination of government support and public acceptance. Municipal governments see driverless taxis as a solution to chronic congestion and pollution. They are actively working with companies to designate operational zones, provide necessary permits, and even integrate these services into public transportation networks. The public, in turn, has shown a remarkable willingness to use these services, partly due to the high-tech savviness of the urban population and the tangible benefits of a safe, clean, and predictable ride. The effect on urban mobility is transformative. An autonomous fleet operates as a coordinated system, not a collection of individual agents. The vehicles can communicate with each other and with city infrastructure. This allows for platooning on highways to save energy, optimizing routes in real time to avoid congestion, and dramatically reducing the need for parking, which currently consumes a huge amount of valuable urban real estate. A robo-taxi is almost always in motion serving passengers, rather than sitting idle for 95% of the day like a personally owned car. The technological stack behind these vehicles is incredibly complex. It's a fusion of LiDAR, radar, high-resolution cameras, and powerful onboard computers running sophisticated neural networks. These systems generate a 360-degree, real-time model of the world around the car, allowing it to identify pedestrians, cyclists, and other vehicles with a level of reliability that is beginning to surpass human perception. The sheer amount of data collected by these fleets in China's complex, urban environments provides a crucial advantage in training and refining the AI. Think about the second-order effects. If transportation becomes a cheap, on-demand utility, the very concept of car ownership in cities could become obsolete for many people. This frees up household income and completely changes the urban landscape. Garages can be converted into living spaces, and vast parking lots can become parks or housing. It also dramatically improves accessibility for the elderly and people with disabilities, providing them with a newfound level of freedom and mobility. It's a fundamental re-architecting of the relationship between people and their cities. By 2025, several Chinese cities will have large-scale, commercially operational driverless taxi networks that are a normal part of daily life. This will give China a massive lead not just in autonomous driving technology itself, but in the operational science of managing large autonomous fleets. They are solving the problems of fleet maintenance, charging logistics, customer service, and regulatory compliance at scale. While others are still debating the what-ifs, China is deploying the right now, creating a blueprint for the future of urban transportation. For as long as we've had cars, we've dreamed of making them fly. The idea of escaping traffic by simply ascending into the third dimension is, honestly, incredibly compelling. The technical term for this is eVTOL, or electric vertical takeoff and landing aircraft. For years, this was really just the domain of startups and prototypes, but in China, companies like Ehang and Xpeng Aero HT are moving aggressively from concept to commercial reality. They're not just building prototypes, they're actually building the manufacturing capacity and seeking the regulatory approvals needed to make flying cars a real part of the transportation mix. The core technology here relies on distributed electric propulsion. Instead of one large, complex combustion engine and rotor system like a helicopter, these vehicles use multiple small, simple electric motors and propellers. This setup provides a high degree of redundancy, so if one or two motors fail, the vehicle can still fly and land safely. It also makes them significantly quieter and more energy efficient than traditional helicopters. The progress we've seen in battery energy density and electric motor efficiency is what has finally made these designs viable. China's progress is most visible in the real-world demonstrations and the push for certification. EHang has conducted thousands of trial flights with its autonomous aerial vehicles, carrying passengers in various cities across China and even in other parts of the world. XPeng's Aero HT has developed a vehicle that looks just like a car and can drive on roads, but also has fold-out arms with propellers to take to the air. This dual-mode approach is a really clever piece of engineering, aiming to bridge the gap between ground and air travel seamlessly. The potential to transform transportation is immense, especially in a country with so many densely populated megacities and geographically challenging terrain. Flying cars could be used for short-haul air taxi services between city centers and airports, bypassing traffic entirely. They could provide emergency medical services, reaching accident sites much faster than ground ambulances. In more remote mountainous regions, they could offer a vital link for transporting people and goods, connecting communities in ways that were previously impossible or just way too expensive. The regulatory environment is a key enabler here. The Civil Aviation Administration of China, or CAAC, has been working proactively with these companies to create a new regulatory framework for unmanned and low-altitude aerial vehicles. They're establishing air corridors, communication protocols, and safety standards necessary for this new form of air traffic. This government-industry collaboration is crucial for moving from experimental flights to a commercially viable service. It's a pragmatic approach to integrating a disruptive technology safely. Of course, the challenges are still significant. Battery technology needs to keep improving to allow for longer flight times and greater payloads. Air traffic management systems need to be developed that can handle thousands of these vehicles flying in urban airspace at the same time. And public acceptance is another factor. People need to feel safe and confident in this new mode of transport. However, the systematic way these challenges are being addressed in China is what really sets their efforts apart. By 2025, we'll see the first certified commercial flying car services begin to operate in select Chinese cities. It might start with specific routes, like from a downtown vertiport to the main airport. But this will be the beginning of a whole new transportation network layered on top of our existing roads and rails. China is positioning itself to be the first country to deploy flying cars at scale, not as a novelty for the rich, but as a practical component of a multimodal intelligent transportation system. They're literally building the future in 3 dimensions. AI is the new electricity. It's a foundational technology that will power every industry in the 21st century. And the heart of any AI system is the hardware it runs on, the specialized chips that perform the trillions of calculations per second needed for deep learning. For a long time, the world has been dependent on just a handful of companies, mainly in the United States, for these high-performance AI chips. China recognized this dependency as a critical strategic vulnerability and has launched an all-out effort to develop its own homegrown AI chip industry. This isn't just about copying existing designs, it's really about building a complete, vertically integrated semiconductor ecosystem from the ground up. That includes everything from chip design software and fabrication processes to packaging and testing. It's an incredibly difficult and capital-intensive endeavor. But through massive state-backed investment funds and a coordinated national strategy, Chinese companies like Huawei, with their Ascend chips, Alibaba, with their Yiqian chips, and startups like Biren Technology are making truly remarkable progress. The achievements are tangible. Huawei's Ascend 910, for example, was designed to compete directly with the top-tier chips from NVIDIA. While geopolitical restrictions have complicated their manufacturing, the design prowess is undeniable. Biren Technology's BR100 chip, before it also faced restrictions, demonstrated performance that actually surpassed contemporary market leaders on certain AI workloads. This just shows that Chinese engineers are more than capable of designing world-class, cutting-edge silicon. The challenge now is mastering domestic, high-volume manufacturing at the leading edge. The implications for global tech dynamics are honestly pretty profound. A world where China is self-sufficient in high-end AI chips is a world with 2 parallel competing tech ecosystems. This could lead to a decoupling of technology stacks, where a company might have to choose between a Western-centric or Chinese-centric AI platform. It would create intense competition, which could drive down prices and accelerate innovation, but also create new geopolitical tensions and challenges for global standards. The focus isn't just on high-end data center chips, but also on edge AI. These are smaller, more power-efficient chips designed to run AI algorithms directly on devices like smartphones, cars, cameras, and factory robots, without needing to connect to the cloud. China is already a world leader in manufacturing these devices, so creating their own edge AI chips is both a natural and strategically brilliant move. It allows them to embed intelligence into the trillions of devices they produce, creating a vast, interconnected network of smart hardware. The government's Made in China 2025 initiative was really the catalyst for this push, identifying semiconductors as a core priority. This has led to the creation of new fabs, semiconductor fabrication plants, research institutions, and university programs all focused on closing the gap with the West. While they still face significant hurdles, particularly in acquiring the most advanced lithography equipment, the sheer force of will and capital being applied is narrowing that gap faster than many observers thought possible. By 2025, China will have significantly reduced its reliance on foreign AI chips for many applications. While they may not have fully caught up at the absolute bleeding edge of manufacturing process nodes, they will have a robust, high-volume domestic industry capable of producing powerful and competitive chips for their vast internal market. This silicon independence is the bedrock upon which their broader ambitions in AI, autonomous systems, and smart cities are being built. They're forging their own path, 1 nanometer at a time. For decades, nuclear energy has been a paradox, a source of immense carbon-free power, yet plagued by concerns over safety, long-term waste, and weapons proliferation. The dominant technology, based on uranium-fueled, water-cooled reactors, has inherent risks. But what if there was a different way? China is pioneering a path forward with a technology that has been researched for years, but never commercially deployed: the thorium molten salt reactor. It represents a fundamental rethinking of nuclear physics and engineering for safer, cleaner energy. Thorium itself is not fissile, meaning it can't start a nuclear chain reaction on its own. It has to be kick-started by a fissile material like uranium. Once it starts, the thorium absorbs neutrons and transmutes into uranium-233, which then fissions and produces energy. This process is fundamentally safer. In a thorium reactor, the reaction is not a self-sustaining chain reaction in the same way as a uranium reactor. If the process is disturbed or the external neutron source is shut off, the reaction simply stops. A meltdown, in the traditional sense, is physically impossible. China's pioneering effort is not just a lab experiment. They have built and are now operating the world's first experimental thorium molten salt reactor in the Gobi Desert near the city of Wuwei. This is a real physical plant designed to test the viability of the technology at a practical scale. The reactor uses molten fluoride salts as a coolant instead of high-pressure water. This is a key safety feature. The salts operate at high temperatures but at atmospheric pressure, eliminating the risk of a high-pressure explosion like the ones at Chernobyl or Fukushima. The role of these reactors in clean energy could be, honestly, revolutionary. Thorium is about 3 to 4 times more abundant in the Earth's crust than uranium. China has significant domestic reserves of it. The waste produced by a thorium reactor is also far less problematic. The long-lived radioactive waste is a fraction of what a conventional reactor produces, and its radiotoxicity drops to safe levels in a few hundred years, rather than tens of thousands of years. This dramatically simplifies the problem of long-term nuclear waste storage. Furthermore, the high operating temperature of molten salt reactors makes them much more efficient at generating electricity. This higher efficiency means more power from less fuel. The design also allows for online refueling, meaning the reactor doesn't have to be shut down to add new fuel, leading to higher uptime and more consistent power generation. This makes them an ideal source of baseload power to complement intermittent renewables like solar and wind. The Chinese plan is ambitious. The initial experimental reactor is a small 2-megawatt prototype. The goal is to use the data from this plant to design and build a larger, 373-megawatt commercial reactor by 2030. If successful, they plan to build a fleet of these reactors across the country, particularly in the arid western regions where water for cooling conventional reactors is scarce. This could be a key technology for decarbonizing their massive economy and achieving their carbon neutrality goals. By 2025, the data and operational experience from the Wuwei prototype will be crucial. It will validate the computer models and materials science, paving the way for commercial deployment. China's leadership in this area is undisputed. They are taking a technology that has languished on the drawing board for over 50 years and are investing the resources and engineering talent to make it a reality. They are not just building a new type of power plant, they are potentially unlocking a new paradigm for safe, abundant, and sustainable nuclear energy for the entire world. The final frontier of human-computer interaction is not a keyboard or a touchscreen. It's the direct connection between the human brain and a digital device. This is the realm of brain-computer interfaces, or BCIs. For a long time, this technology was confined to medical research, helping paralyzed patients control prosthetic limbs or communicate. Now China is at the forefront of pushing BCIs beyond the medical field and into consumer and industrial applications, exploring the potential to fundamentally augment human cognition and control. The technology generally falls into two categories: invasive and non-invasive. Invasive BCIs, like the ones being developed by companies like Neuralink, require surgery to implant electrodes directly into the brain, offering very high-resolution signals. Non-invasive BCIs, typically using an EEG headset that reads electrical signals from the scalp, are safer and easier to use, though the signal is noisier. Chinese researchers and companies are making significant progress on both fronts, but their focus on practical, non-invasive applications is particularly noteworthy. For example, companies are developing BCI-powered headsets that can monitor a worker's attention levels. In high-stakes jobs like air traffic control or operating heavy machinery, this technology could be used to detect fatigue or distraction and issue an alert, potentially preventing accidents. In education, BCIs are being trialed to monitor a student's focus during a lesson, providing feedback to the teacher about which parts of the material are most engaging or confusing. These applications raise significant ethical questions, but the technological capability is being actively developed. In the medical sphere, China's advancements are also profound. Researchers at Zhejiang University have demonstrated a system where a patient with a BCI implant was able to control an external robotic arm with a high degree of dexterity, allowing them to grasp objects and even play a game of mahjong. This level of fine motor control represents a major leap forward. They're also exploring how BCIs can be used for neurofeedback to treat conditions like depression, ADHD, or to aid in stroke rehabilitation by helping the brain rewire itself. The convergence of BCIs with AI is a critical factor. The raw signals from the brain are incredibly complex and noisy. Advanced AI algorithms are needed to decode these signals and translate them into clear, actionable commands. China's strength in AI is giving its BCI researchers a significant advantage. They can use machine learning to filter out the noise, identify specific neural patterns corresponding to intent, and create more intuitive and responsive control systems. The long-term vision is one of seamless human-machine symbiosis. Imagine being able to control your smart home devices just by thinking or typing on a screen without moving your hands. Imagine a surgeon controlling a robotic surgical system with their thoughts, achieving a level of precision impossible with human hands alone. This is the future that BCI technology promises. It's about reducing the bandwidth limitation between our thoughts and the digital world. By 2025, we will see a proliferation of non-invasive BCI devices in the Chinese market, initially focused on wellness, education, and gaming. The data gathered from these consumer devices will be invaluable for refining the algorithms and improving the technology. While widespread invasive BCIs are still further out, China will have established a strong foundation in the underlying science and engineering. They are not just treating BCIs as a niche medical device, but as a foundational platform for the next generation of computing. A city is the most complex machine that humans have ever created. It's a chaotic system of systems, transportation, energy, water, waste, emergency services, and millions of individual people. The traditional approach to managing this complexity has been piecemeal and reactive. China's vision for the smart city is something entirely different. It's about using AI to create a centralized, holistic urban brain that can monitor, analyze, and optimize the entire city in real time. It's a data-driven approach to urban planning and management on an unprecedented scale. The city of Hangzhou, home to Alibaba, is a prime example. The City Brain project there began by tackling traffic congestion. By analyzing data from millions of traffic sensors, GPS data from cars and buses, and video feeds from intersections, the AI can dynamically adjust traffic light timings across the entire city. It can identify accidents in seconds and automatically dispatch emergency services while rerouting traffic around the incident. The result has been a significant reduction in congestion and faster emergency response times. This is just the beginning. The features of these AI-powered smart cities extend to every aspect of urban life. AI algorithms optimize energy distribution on the power grid, reducing waste and preventing blackouts. They manage water resources by predicting demand and detecting leaks in the system. Smart trash cans signal when they are full, allowing for optimized waste collection routes. The city is no longer a static collection of infrastructure, it's a dynamic, responsive organism. The influence on urban planning is profound. New cities like the Zhong'an area being built near Beijing are being designed from the ground up with this AI infrastructure at their core. The city is being built with a digital twin, a complete virtual model that is updated in real time. Planners can use this digital twin to simulate the effects of new buildings, transportation lines, or policy changes before they are implemented in the physical world. This allows for a much more intelligent and evidence-based approach to urban development. The backbone of these smart cities is a massive network of sensors, cameras with computer vision, IoT devices, and environmental monitors, all feeding data into a centralized cloud platform. This, of course, raises significant questions about privacy and surveillance. The level of data collection is immense. From the government's perspective, this data is essential for efficient management and public safety. For citizens, it represents a trade-off between convenience and privacy that is being navigated differently than in the West. The system also integrates services for citizens. A single app on a smartphone can serve as an ID card, a public transport pass, a tool for paying utility bills, and a way to book doctor's appointments. This level of integration creates a seamless and efficient experience for residents, but it also further centralizes data about individual activities. It's a model of governance that is deeply intertwined with technology. By 2025, dozens of Chinese cities will have implemented sophisticated city brain platforms. They will be competing with each other to become smarter, creating a powerful internal market that drives rapid innovation in urban AI technology. China will be the world's leading laboratory for AI-driven urbanism, generating vast amounts of data and operational expertise. They are building a blueprint for the city of the future, one that is more efficient, more responsive, and more deeply integrated with artificial intelligence than we've ever seen before. So, what does this all mean? When you look at these 8 areas in aggregate, you see a clear pattern. This isn't a random collection of projects, it's a coherent multi-decade strategy to achieve technological leadership across the fundamental pillars of the 21st century economy. From the quantum realm to outer space, from the code in our minds to the concrete of our cities, a profound transformation is underway. The rate of progress is the most important variable, and the velocity of innovation I see in China is, frankly, astounding. It's a force of nature. We can't afford to be complacent or dismissive. The physics of progress doesn't care about politics or rhetoric. It only cares about iteration speed, talent density, and ambition. China is optimizing for all three. This isn't a zero-sum game. A breakthrough in thorium reactors or AI-driven medicine in China can ultimately benefit all of humanity. But we must also be clear-eyed about the competitive landscape. A future where one nation has a monopoly on transformative technologies like general AI or quantum computing is not a stable one. It creates an imbalance that is dangerous. The path forward for the rest of the world is not to try and stop China's progress. That's impossible and counterproductive. The path forward is to innovate faster, to be more ambitious, to reignite our own engines of creation, and to build a future that is so inspiring and compelling that it pulls humanity forward. We need to be building more, taking more risks, and focusing on fundamental engineering challenges. The future is not pre-written. It is built by those who show up and do the work. The question we all need to ask ourselves is, are we doing enough?